Hi everyone, welcome back. In this video, we're going to talk about natural deduction problems. At first, these can seem really confusing, but with a bit of practice, we'll get really good at it. All right, let's get started. Now in this example, we're looking at an argument that has, well, four premises and then the conclusion. The conclusion I usually like to call the challenge bar, so we'll circle that here. And in this case, the challenge is we need to prove if G, then E. So when I do these myself, I usually like to look to see, well, is there something that is the thing I want in the premises somewhere, or something that I can make, or I can put together to make the thing I want. Now I look up here, and well, immediately I don't see the argument itself, or I don't see the if G then E, but I do see right here two conditionals, if G then T and if T then E. And I know that if I can use hypothetical syllogism, right, then eventually I can use hypothetical to put those together and get the result I want. Now, one thing to keep in mind with these proofs, when we worked with truth tables, we know that the truth tables, we often have to work from little to big. Here, it's the opposite. We have to work from big to small. So we have to take apart the big sentence before we can take apart the little sentences. Well, now we ask ourselves, what can we put together? And if you look, you'll see that I can actually take number 1 and number 3 and put those together. Number 1 says if P, then G, then T. 3 says P, therefore, that gives us 5. If G, then T. And remind ourselves, we always have to put the justification to the right. And that means the lines we used, and that's 1 and 3, and the rule. And in this case, that's modus ponens. So now, are we done yet? No, because we haven't met the challenge. Well, what else can we put together? Look at 2 and 4. And you'll see here, 2 says if Q, then T, then E. And 4 says Q, therefore, that gives us 6. T, then E. And again, we have to justify it. So we have lines 2, 4, and modus ponens again. Now, are we done yet? No. But remember our strategy from earlier. We wanted to put these together. Well, now G then T and T then E are on a line by themselves. Now we can put them together. So if G then T, if T then E, therefore, if G then E. And notice that's what we wanted. Well, we just have to justify it now. We used lines 5, 6, and hypothetical syllogism. Now, I want to take one more look at this argument. It turns out there's another way you could write out the proof if you find this more, I guess, easy to see. I learned this from a student, actually. I'm going to do the same proof as before, but this time I'm just going to write out the steps a little bit differently. The student I used to have used to solve these like this. So they would take the premises and rewrite them. So they would have 1, here we go, 1 and 3. And so 1 says if P, then G, then T. And 2 or 3 says P. And then they would use that together and put those together to give us, well, the new 5, which was G, then T. And then over off to the side, they would write modus ponens like that. And then, well, just put a little bracket around these. And then below this, well, they would write 2, 4, right? Reduplicating again, if Q, then T, then E, Q, and that would give us the brand new 6. 6 being T, then E, and again, the justification over here to the right. And then you would just carry on the proof the rest of the way the same way. Now again, some students, as I said, find this a lot easier. I like to call this the longhand way of doing it. But the key idea is that this proof, the way it's written, contains the same information as the earlier one. So I guess it's up to you whether you prefer shorthand or longhand. Now we're going to look at a different example. This is number 10. Now I want to use this one to illustrate something. Sometimes the sentences we're working with can look really complicated, but I want to show you a trick real fast. Now we know here that our challenge is we want to find D. So that's the challenge. Now, but if you look at number one looks super confusing. Well, let's deal with number one in a moment. We know to start that we can put 2 and 3 together here. 2 says O or G. 3 says not O. Therefore, well, that gives us number 4, which is going to be G. And we get that from 2, 3, and disjunctive syllogism. Okay. Now, I just want to say something about 1. We notice that 1 looks really complicated. If G, then, well, there's a not O, and there's a G, then D. It's a bracket within a bracket, so it looks like a mess. But simple trick here, when I see these brackets, I like to remind myself that these are basically just boxes. And so if I'm looking at something super complicated like this, what I will sometimes do is I will read this as if G, then, well, let's call it box of stuff. Okay. So it really doesn't matter what's in the box. All that matters is it's a conditional. Okay. So then you take a look at 4. 4 is just G. Oh, and then look at this. 4 combined with, well, whatever's in 1. If G, then box of stuff. Pretty simple. Now we know that that will give us 5, which is whatever was in the box of stuff. Well, we take it out of the box, and that gives us not O, then, well, another box of stuff. G, then D, like that. And so, right, that's pretty simple. It's 1, 4, and, well, very simple modus ponens. Okay, reminding ourselves we still want D, and D is inside our little box of stuff, so we have to take apart the big sentence. Well, look up here. Number 3, well, we already had that as a given. That was O, or not O in this case. So we just have to put 3 and 5 together, right? And 5 says, if not O, then, well, box of stuff. So that gives us, well, combined with not O, that gives us, well, the box of stuff. We take it out. We go G, then D. And that was 3, 5, and in this case, modus ponens again. Finally, well, we wanted D by itself. Oh, and look at this. Line 4 had G sitting there, so if G, then D. G, therefore, well, 7, which is D. And that, of course, is 4, 6, and in this case, once again, modus ponens. Now, I wanted to look at one last example. One of the common issues that students tell me they have is with double negations. And here in number 3, you actually see that we have a double negation right there. Now, a couple things I want to say here. One, students often ask, well, hey, I see a double negation sitting here, not n, so can't I just convert it to n? And, well, I guess my answer here would be, yes, there are rules that will allow you to do that, but right now we're working with what I call the basic pack. If you think of this like a game with rules, and this rule here is part of the expansion pack. And so we're not working with that. And now if you take an advanced logic course, yeah, sure, there you'll use the expansion pack. But for now, we've got to keep not n by itself. So we're not allowed to use that rule. Okay, so take that away. So let's go back here. Our problem here says we want to find not u. And notice it's already right here inside this box. So really all we need to do is take apart this disjunction and we're there. This argument actually gives us two ways we could put this together. We could put together 2 and 4, as we see here, or, as you'll see, we can put together 1 and 3. Okay. So I'll tell you what, for our purposes here, let's put together 1 and 3. You'll notice that 1 is set up so that it says it's a disjunction. It says not n or stuff, okay, over here to the right. And then number 3 says not n. So real quick, one way to think of that is if we write it out here, not n or, well, stuff, like our previous example. Now below that, for writing, we would write not n. And notice what that does. The negation always takes away whatever is to the right of it. So if you thought of this as like being in a little box, well, we're negating that, taking it all away, and so we get the remainder, which is the stuff. We're going to put together 1 and 3, not n or stuff, not the case that not n, so that gives us 5, which is, in this case, we take the stuff out of the box, C or not U, okay? And again, we have to justify it. So we have, in this case, 1, 3, and in this case, disjunctive syllogism. Now, in this case then, well, we know we want not U ultimately, and we need to negate the C here. That's what we need to take away. So we need to build a not C. So in this case, we're going to put together 2 and 4. 2 says if C then X, 4 says not X. And so we know we can conclude from that, not the case that C. So in this case, this would be 2, 4, and modus tollens. Now we're almost there. 5 says C or not U. Well, 6 says not C. Therefore, well, that's a straightforward disjunctive syllogism. So in this case, not the case that U, and we get that from 5, 6, disjunctive. I hope you found this helpful. Thank you for watching, and I'll see you in the discussion boards. Take care.